The American-French mathematician Benoit Mandelbrot is very largely responsible for the interest in fractal geometry and the chaos theory that emerged in the 1980s. Fractals are firstly only mathematically defined objects which are not 1, 2, or 3-dimensional, but something in between. It is impossible to imagine that clearly. Nevertheless, objects occur in nature which come close to such fractals. Structures can be found in them that repeat themselves and which are similar when considered approximately or in detail. That is why we also talk of self-similarity. An especially beautiful example of fractal geometry in nature is the Romanesco, a green variety of cauliflower. But it was not so much the scientific significance as the possibility of producing pictures of great aesthetic appeal using simple algorithms and the computer that no doubt contributed to the popularity of fractals. The most famous of them is probably the Mandelbrot set. In it, similar but repeatedly new and incredibly beautiful structures are revealed in the area of their edges with every enlargement. What do fractals have to do with the Fibonacci numbers? The apple shapes of the Mandelbrot set, which vary in size, arise in different periods of the repetition of mathematical algorithms. If we examine these apple shapes, we make the following observation. Of all the apples between one apple of period 2 and one apple of period 3, it is the apple of period 5 that is the largest. In exactly the same way, of all the apples between period 5 and period 3, it is the apple of period 8 that is the largest. And of the apples between that of period 8 and that of period 5, it is the apple of period 13. All numbers from the Fibonacci series.